Good afternoon, Algebra II students. Today we are going to be talking about the power property of logarithms. This will be the first property of logs that we're going to start with as far as our Chapter 7 goes. I know we just got done talking about three-dimensional graphing and then curve fitting for 3 points for a parabola, and now we're going to jump back into logarithms for just an apparent reason of because we decided to. So I'm going to take you back a moment just to a type of problem that we've seen in the homework in the past. 5 to the x equaling 15. Now, I said we got to do guess and check for this thing. One day I kind of showed you the shortcut, and the shortcut really is this power property of logs that we're going to discuss right now. If you were to go into your calculator, at least try to reason this out a little bit. Think of 5 to the first power, you know, is 5, and we go to 5 squared, which we know is 25, and 15's got to be somewhere right between there. So, if you want to take a moment right now, you can stop the video and go out to, well, let's say 4 decimal places to see if you can't come up with a 1 point whatever it needs to be to get something that's pretty darn close to 25. So, pause your video. So as I look at my calculations on this thing, I get 5 to 1.5 to the 1.6827, right between there. That's where I cross over between 14.9998 and 15.0226. So looking at this, we're going to say, okay, this has got to be some kind of a result of some log thing that we're going to do up here with that first problem. What I'm going to do now is I'm going to retake this problem, 5 to the x equals 15, and I'm going to use this logs to get this x thing by itself. Keep in mind, the reason why I'm doing this is that the logarithmic function itself is just the undoing of the exponential. So as I do this, keep that in your mind as you're looking at it and saying, oh, okay, yeah, I understand. If square gets rid of square root, log is going to get rid of the exponential. It's not going to make x disappear, we're just going to reposition it so that it's no longer in that exponential location. So, I'm going to take and I'm going to slap a log on both sides of this equation. Again, you want to make sure that you do things on both sides of the equation equally, because that's just good algebra. This x, he gets not misplaced, but he just gets moved out front. So that's kind of the idea in this property, the power property of logs, is that anything that's an exponent position is going to get moved out in front of the log. Rewriting this, x log 5 equals log 15. Well, we know that these two are just numbers, the log 5 and the log 15. Again, it's that 10 to what power equals 5 and 10 to what power equals 15. So we know that it's just going to be some number, some exponent, but if I divide it off of both sides, we can do that because algebraically it's just good math. You get x equals log 15 divided by log 5. So as we get out our calculators, and I'll come up nice and close for this one, take log 15, and please make sure you close your parentheses on those kinds of problems. Log 15 divided by log 5, close parentheses, and we'll see just how close my approximation was. Now you can see the 1.68260619, blah, 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 blah. So they're saying that there's another 06194. So it looks like my 4 decimal places are pretty darn good for this problem. That is the shortcut, maybe not so much a shortcut, but how log and the exponentials kind of undo one another in terms of this type of equation. Let's make sure that that is indeed true, so I'm going to come over here and put up another problem. I'm going to say the log of 4 cubed, and we're going to see if this does equal, think about the exponent moving out front, 3 log 4. So go ahead and grab out your calculators again and let's do this calculation. Going to clear this out. We got the calculator, so log, and it's going to put parentheses on there for me already. Let me get it tipped up right there. Log 4 to the 3rd power, and that gives us 1.8061799. And again, what I'm checking to see right now is that I just typed this into the calculator. I'm going to type this in also, and the idea is that with that logarithm, it's going to take that exponential and pull it down front, like we have right here. So we know this is 1.806179974. And in your calculator, you can do it now, 3 log 4. You hit enter, and sure enough, it gives us the same exact number. So it looks like we have a rule, something that we can apply to this thing, that's going to work every single time. If I go and give myself a new sheet of paper, well, I won't use a new sheet, we'll just shrink this down like, my favorite thing to do. But it looks to me like if we have some b to the x, and we put a log out front, that this is going to equal x log b. Again, log is the undoing of the exponential. X used to be in the exponential's location, and as soon as we log it, pulls it down front. It doesn't make it disappear like x squared and the square root the square root of x. Those will disappear. This one, it doesn't work that way. However, the log will still undo that exponential position in this equation. This is a pretty important property, and make sure you use it the way it's supposed to be used. Keep in mind, we can throw any kind of an equation up here, but still treat it as a b and an x, and parentheses, an x out here, and this b in parentheses. You can still use that to give you the general idea of where the exponent is, where the base is, where the log is, and then how they just reposition themselves when we combine log and an exponential together. If you have any questions, feel free to get a hold of me. If not, enjoy your logarithmic property for exponents.